in skulls, they can perceive light through the top of their skull to this eye. This is your third eye that your mom always said she had when you were doing things wrong. It's on the top of the head. And what it does is it sends messages down to, of all places, the hypothalamus. It can signal, remember the hypothalamus has a lot of control over daily activity and things like that. It is also important, the hypothalamus is this larger structure here. But this here is called the pineal gland. And the pineal gland is one that's involved in daily rhythms. It releases melatonin. And you probably see advertisements about sleeping problems and everything. Melatonin is something you can take. Melatonin comes from the pineal gland. So it's signaled from that top of the brain. There's actually neurons that run down and say, okay, now's the time to release melatonin. And so it regulates your what you do, when you get sleepy, when you don't, those kinds of things. And you just can see it in the lizard. So it's also important in circadian rhythms in terms of seasonal changes too. It can stimulate the reproductive cycle of a bird, for example. When the days are getting longer, you can take a bird and blind it, and it can still perceive the lengthening days and still go into reproductive mode. It's not visible in most of the rest of the lizards, but the tuatara you can see the little spot. Now some of the lizards will have some light areas on this area, but that may be involved in sending some information, some light penetrating through. But yeah, when the tuataras get older and the scales are heavier, then it doesn't show up. Some other things that are different about the lizards is that the teeth are, well, there's several different kinds of teeth, but they're getting some more support. With fish, they were just, the teeth are just laid on the bone, and they're all over the mouth of the fish. And in the amphibians, they tend to just be on the mouth, and then you can find them on the tongue occasionally. You can find it on other parts, but just a few of the bones in the roof of the mouth. When we get to the lizards, it's pretty much just the jaw. Now, there are some with some additional teeth, but if it is, it's just a couple of rows on the roof of the mouth.
Is that what acrodont means?
Excuse me. Well, the lizards that are primitive, like or the lepidosaurians, like the tuatara, yeah, the teeth just set on the top. There's a little bit of an indentation, but they usually just set on the top. With some of the advanced lizards, the teeth are embedded down in the jaw a little bit more, and they'll have support on the side. And those are called pleurodon. So these will be the two types of teeth that we will see in lizards. Thecodon will be embedded all the way down, and that's actually what we're going to see with mammals too. They'll have the tooth that's deep down in there. And as you can imagine, you twist or pull with your jaw, a tooth that's just sitting on the top is going to have a tendency to break off. If it's embedded down in, that's going to stand stress a little bit more. And you've seen that in the skull and the mammals. When you pull the skull out, or the tooth out, if it falls out, there's a big hole.
You said the acrodonts for the tuatara, right?
Yeah, the tuatara has acrodont type teeth.
But lizards in general, either acrodonts or pleurodonts?
Core lizards, yes. Yeah. All right, so now we're to the squamata, and I'll go through these, not necessarily in the order there, but the order they've got them in has a little to do with how they're related to each other. The iguanid is a New World group that you're probably familiar with. Iguana, get large, they're found in Central America. Actually now there are a lot of them in Florida because they got away. Usually large and green or brown. This is a pterosaur. This is a basilisk, which is a one that tends to hang around water. Basilisk. It's sometimes called the Jesus Christ lizard.
Right.
Oh,
Yeah, because they can, I don't know, maybe I can,
The ones that run on water?
yeah, I don't know, I didn't look. Probably can find a video. It's pterosaur. Don't, let's see. Got it. I think they give you a list of some of the members. They're mostly herbivorous iguanas. Pterosaurs are just not. Don't worry about it. Pterosaurs are just another big iguana. But the basilisk is one maybe worth looking at. Let's see if we can find it. See if this might show one.
The Goldman Sachs 10,000 Small Businesses program provides business skills to entrepreneurs. See how small businesses are driving economic progress in their community.
Basilisk. We used to see them in Costa Rica. We'd catch them at 9. Because it was the only time we could catch them. And then the next day we would drop in the water to watch them run across the water.
Basilisk lizard. When afraid of winged insects, you need to be
So way they get away from the predators.
That was a female, right? Then only the males have the crest.
The crest is just bigger than male.
Oh, okay.
The female will have it. This is just a young one.
It displays one of the most spectacular capabilities in nature.
So they've got long toes and they use the surface tension of the water to walk. And it's mostly on their hind
I'm not
legs.
impressed by this superpowers.
Well,
Telling us we shouldn't believe what we see on TV.
well, no, that's accurate, actually. Okay. All right, so that was the iguanid. Yeah, the crests, you see several lizards that have crests like these, and they can fold them down. I'm going to talk more about that in a little bit. A related group, and these used to be in the iguanid, the Dactyloidea are the anoles. They're sometimes called chameleons because they can change color. The ones we have locally are green like this when they're warm and happy. When they're disturbed and cold, they turn brown.
Oh.
And so they call them chameleons, but there's actually another lizard that's a chameleon. But they do change colors. Really diverse group, found on islands throughout the Caribbean. It's a New World species, or New World genus. So quite diverse. And they all have this little, the males have these are called dewlaps. Or throat fans, and they use them to attract the females. And they're also species specific. Again, females produce the eggs, and the eggs are expensive. They got a lot of yolk. Females don't want to make mistakes. Sperm's cheap. The male makes a mistake, mate with the wrong species, he's wasting a little sperm, but he can make more. Females, if they waste their eggs, they've lost maybe a whole year. So they have to make sure they get the right species. So the way they do that is with these displays, and the displays, the male bobs up and down. Some of the iguanids do that too. And then the colored fans will show up, and they'll have different colors on different islands. You may have 3 or 4 species in the same place. And I'll show you. Go back to Google again.
So how fast can they change from like green to brown?
Not, it takes a minute or two.
Because I was trying to catch one, and then it was green, and then when I looked exactly the same size, it came out brown. So I don't know if it was the same one or not. Just upset.
They can change it in fairly quickly. These aren't the ones I looked at this morning, but maybe we'll get a good one. So it's kind of a combination of the push-ups and this dewlap. Now some of them use all 4 legs, some of them just use the front legs. And then the pattern, and then the flash of the throat fan will be the signal. So you can have a number of species on the same tree, and they separate out their breeding habits that way.
There's a video down there called Annoying Wars too.
Actually, this is the one I'm going to watch. This is one. I saw this one. I looked at this one this morning.
See, Bryce? He's trying to stroke it. Yeah.
He's changing color pretty fast. So they do use it for territoriality, but also to attract females. They'll actually display, the local ones will display it to us, which is kind of weird. If you get up close to them, you walk up close, sometimes they'll display it to you.
So is it a defense thing too then? Or?
No, I think they're saying this is my territory, leave me alone. I mean, you get closer, they'll run away. Sometimes there'll be spots in there. Sometimes those things will be lots of different colors. So this figure out of your book kind of shows some different species. All right, so it's called a dewlap. Phrynosoma, also closely related to the iguanidae. These get their protection more by having very spiky scales. We have one called the fence lizard locally, because they would set out on fences. This little brown guy here, and their scales are really rough and they're sharp on the end, and it can make it hard to swallow them and that kind of thing. Although they run away mostly. And then another one that we used to have in East Texas, but they're almost pretty much gone, is the Texas horn lizard. A much flatter one, but it also has lots of spikiness all over its back. Makes it hard to swallow. Phrynosoma are New World only. The horn lizards and fence lizards are the main ones that we have. The horned lizards also, they've got, part of the reason they've disappeared is because they eat ants, and they eat only harvester ants. Harvester ants are those leafcutter ants that make a big mound of, and they'll make a fungus garden, and so they're carrying leaves back to their nest, and the horned lizard will find a trail of ants and just sit there picking them off one after another. But we sprayed all of our ants because they would also kill people's crops. So we sprayed them all and killed all the ants, and so these guys have disappeared. There's also some evidence that the fire ants that have come in and eaten their eggs and so on. Because these guys, I used to see tons of this lizard, but I haven't seen one in years. So they've disappeared too. And they don't eat ants, they'll eat any sort of insect. These guys also have the defense. If you can see the big horns on the back of the head. They also, if you pick them up, they can squirt blood out of their eyes. I'm not sure why that would cause a predator to drop them or whatever, but they do that. An old world group of lizards that show a lot of convergence with the lizards that I've talked about in the New World, the iguanidae and the Phrynosomidae and so on, are the agamids. The agamidae is a pretty diverse group of ones found in Australia and Africa, some up in Asia. And some of them are ground dwellers, look a little like some of our iguana types, and can get large, and some of them are vegetarian. Some of the ones in Australia are a little weirder. This is one actually from Thailand that can glide. So it's volant, like the flying squirrel is. And what it does is it has these big flaps of skin between its hind legs and its front legs, jumps off of a tree, and it can glide to the next one. And then the frill dragon has these big flaps of skin, and they get pretty good size. And the males in particular will spread out this big frills and try to scare you away.
So that's more territorial than it is mating display?
It's actually probably, well, it's probably that, but it also is involved in defense. And they'll display and try to look bigger and so on. It's kind of like the one that what's the one in Jurassic Park that has the...
Yeah.
Holes.
Oh, the movie Holes?
Oh, is it in the movie Holes?
Yeah.
Oh, okay, I didn't know that. Is that, that was in Australia?
I don't know
Was it
where.
in Australia?
How would you see it?
Some desert.
Yeah, I think it was, maybe.
You were talking about that.
I actually caught one of these in Australia, and big male, which was kind of a highlight. Like, it was big. Okay, so but the agamids are strictly old, and like I said, convergence is pretty typical, and there's actually a convergent one for our horned lizard, and it's called the horny devil, or sometimes called a moloch. And it looks very similar to a horned toad. And guess what? It eats ants. So it stands over a trail of ants and eats them. So, and I don't know about the blood, whether it squirts blood with the eyes, but it's definitely got a lot of the other traits. A species, an old world species, a group that does not have any similar ones in the New World are the chameleons, though. I mean, we talk about the knoll being, call it a chameleon, but it's really not. These guys can really change their color to match their background. So this is a panther chameleon here, and it can have a pattern that really helps it disappear in the bushes, which is kind of important because they're not very fast. They tend to walk real slowly. They have their toes are separated to where 2 of them are one side and 3 are on the other. It's called zygodactylus. And so they wrap around a branch with their toes and just very slowly walk. And so they'll wave back and forth like a leaf. It's very well camouflaged. Some of them very small to panther chameleons can get a couple feet long. Found in parts of Africa. Sahara, they don't have them. Found out in Madagascar, there are a number of species there. Some in India, but not farther over. Like we don't have these in Australia. Pretty diverse. Some have horns on their heads. The males. This is a Jackson's chameleon with that. Well, one of the other interesting things they do is their feeding habits. So I'm going to do another
Yeah, David Attenborough had a real cool
picture of them eating.
Yeah, video of the eating.
I'm going to see if I can find the one I looked at this morning. They have a really long tongue. I think this might have been one. There are a lot of different ones, but yeah, this is it. I'm sure David Attenborough would be a little better. Okay, you can see the zygodactylus feet. Maybe this isn't the one I was
He knows he's gonna come.
They can stick, the tongue will actually go the length of the body. They go way out. Yeah. You can find a nice one in that probably. It's moving pretty fast. The other thing I wanted to show you was their color change. You can see that playing out. Yeah, zygodactylus. We're actually going to see that with birds today. The birds. Did you notice how some claws on one side, the other two on the other?
Like chameleons.
Just a little. Doesn't he look like a sandwich?
They start sticking their tongues out.
Just a
It's the bottom right.
What's gonna happen? I want to see it.
There is a misconception about chameleons. They
That's
change their
good.
color in order to blend in with their environment. That is actually not the case. When a
Well,
chameleon
they
is
can.
calm, it is green, and so it naturally blends in with its
They also have a
surroundings.
prehensile tail.
But male chameleons change color when they become excited in the presence of a female or a rival male.
And actually,
as
a
shown
female
here.
that's
Look at
pregnant
the
will
first
change
frame
color,
on the
so
bottom right
males
for
know not to
comparison.
bother her.
As you can see, as he becomes more excited, his color changes to be more yellow, orange, and red. So instead of blending in, this chameleon will now stand out. But how do chameleons actually change their color? For years, we thought that there was a simple, well-established mechanism for this color change. In their skin, chameleons have different cells containing colored pigments. Some are yellow, others are red, and some contain the dark melanin pigment. Many animals, including chameleons, are known to turn a darker shade by causing the melanin to spread out along the fingery extensions of the cell. They turn lighter again by condensing the pigment back into one spot. It was assumed that chameleons must turn yellow, orange, and red in the same way, by causing those pigments to spread out in themselves.
Notice the eyes too. The eyes are
New
in
research
circles,
from
so they
collaborating
can
groups of
actually
physicists
look
and
at different
biologists at the
directions.
University of Geneva shows that this is incorrect. Now, the first clue should come from the fact that there is actually no green pigment in a chameleon. The green color is actually created by two distinct mechanisms: pigment color and structural color. Beneath the yellow pigment cells, there are cells containing tiny 130 nanometer crystals, regularly arranged in a lattice. Now, light diffracts off these crystals, and due to the spacing between them, blue light constructively interferes and is therefore strongly reflected, whereas the other colors are not reflected. This is very similar to how a morpho butterfly wing creates an iridescent blue. There is no blue pigment, just the periodic nanoscale structure that acts as a strong reflector for only one color. So a chameleon looks green due to the combination of the yellow light from the pigment plus the blue light reflected off the crystal structure beneath it. So how do chameleons change this green into yellow, orange, and red? Well, previously it was assumed that the color change was achieved by dispersing pigments in the colored cells. But now scientists have found it's actually the crystals underneath which are changing. By increasing the spacing between the crystals, the chameleons can change which color is selectively reflected. Bigger gaps between the crystals are better at reflecting longer wavelengths. So as the spacing increases, the color changes from blue to green to yellow, and then orange and red. Scientists compared skin samples from calm green chameleons and excited yellow chameleons and found that, indeed, in the excited chameleon, the crystal spacing was much further apart. Here you can see a single cell enlarged, and the color it reflects changing from blue to green to yellow, orange, and red. Plus, a computer simulation of the light reflected off crystals while their spacing is decreasing also provides excellent agreement with these observations. Furthermore, applying physical pressure to the skin causes the crystals to compress, and so they reflect more blue light. When that pressure is removed, the crystals expand again, reflecting more green light. The structure of a chameleon skin gets even more fascinating, as there's another layer of cells underneath which also contain crystals. But these crystals are larger, more spaced out, and more disorganized. This means they reflect longer wavelengths in the infrared part of the spectrum, and they reflect a broader range of these wavelengths. It's thought that the function of this layer could be to reflect heat from the sun, since these chameleons live in bright, full sun habitats. So male chameleons don't change their color hue by spreading out red and yellow pigments. Instead, they do something much more remarkable. They actively tune the spacing between nanoscale crystals in order to create structural colors that span the whole length of the visible spectrum. Now, what I find amazing is that in this day and age, we thought we had the answer to how chameleons change color, but it actually took the combined expertise of physicists and biologists working together to figure out what's really going on. This episode of Veritasium was supported by Linda.